Most people think that if you want to build massive dams or manage the world's most critical resources, you have to be a civil engineer. But what if your goal isn't just to build a road, but to keep a whole planet alive? That is where the second major scope of agricultural engineering comes in: soil and water conservation. For someone just joining, we've discussed about the first major scope in Chapter 1. If you've ever seen a lush green field in the middle of a scorching drought, you're looking at agricultural engineering in action. We aren't just observers of the environment, we are the ones who manipulate it to favor life. We design irrigation systems that move millions of gallons of water across hundreds of miles to thirsty crops. In this field, we use different strategies depending on the land. We have surface irrigation, where we use the simple power of gravity to guide water through channels. But when we need to be precise, we move to pressurized systems. This includes massive sprinklers that mimic natural rain, and the gold standard of efficiency, drip irrigation. This is where a tiny emitter delivers one single drop of water at a time directly to the roots. Not a single drop is wasted to evaporation or runoff. But engineering water is only half the battle. We also have to protect the ground it sits on. If the soil washes away during a storm, we lose the nutrients needed to grow food. This is called erosion control. We use math and physics to design structures like terraces and bunds, engineering marvels that literally hold the earth in place on steep hillsides. Then, we look at the third scope: farm structures and the environment. This isn't just about building a barn, it's about building a life support system. If you have 10,000 animals in a single building, the air has to stay fresh and the temperature has to be perfect. To do this, we use the science of psychrometrics, the study of how air and water vapor behave together. We use technical charts to design ventilation systems that keep livestock healthy and productive. This same science allows us to design greenhouses that completely defy the weather. We manage solar radiation and heat so we can grow fresh vegetables in the middle of a frozen winter, or a scorching desert. This part of the field is about controlling the environment so that life can thrive no matter what the weather is doing outside. Agricultural engineers aren't just observers of nature, we are the ones who control it. We manipulate earth, water, and air to make sure life thrives where it shouldn't. It's a mix of physics, math, and biology working 24/7. But the work doesn't stop once the crop is finally grown and harvested. What happens next is a whole new challenge. In the next chapter, we look at the high-stakes world of post-harvest and the future. See you on the next chapter.